Okay, a couple of network performance terms that you'll probably run into. The one you've heard of the most is bandwidth. And you think about your bandwidth maybe at home when you figured out with your local network provider what bandwidth you're paying for. You can have different levels of bandwidth in your package. And that bandwidth comes to you in megabits per second or potentially gigabits per second. And it's important here to understand it's bits, not bytes. In networks, we talk in terms of bits. And a byte has 8 bits in it. So if you have 80 megabits, let's say by your home provider, you've paid for what we would consider maybe a premium package, or you have fiber optics in your neighborhood, and maybe you go up to a gigabit. But make sure that you're then divided. If you have 80 megabits, that's only 10 megabytes. And a lot of times when you're trying to compute the time for a download, whether you're moving megabytes, gigabytes, or potentially terabytes of data, and then you're told that your home or your campus has bandwidth of so many megabits, make sure you do that conversion by 8, or you might be an order of magnitude surprised it's taking quite a bit longer than you thought it was going to. And the next term is latency. And latency is often misunderstood and kind of glossed over when everyone focuses on bandwidth. And it's probably a little less intuitive. Well, let's try to give a couple of examples for this. So if we think of bandwidth as the total aggregate amount of data or something that we're trying to move, let's talk about moving something across the ocean from North America to Europe. If we wanted to move a lot of cargo, a huge amount of cargo, we might put it on a ship. And let's say that ship could take, hundreds and hundreds of containers, but the ship takes 2 weeks to get across the ocean. On the other hand, we could ship that with an aircraft. An aircraft or an airplane might only take us a few hours, but we can't put hundreds of cargo containers on that aircraft. It just wouldn't work. So which do we want? Do we want an aircraft that could get there in a few hours and it could go back and forth and back and forth? Or do we just want to put all that cargo? We need that entire file or all of that data or hundreds of cargo units to get across the ocean. Which do we want? Well, if we're going to have to communicate back and forth, maybe we want the aircraft, so we're moving in smaller segments just in case we move some of the wrong cargo. If we move some of the wrong cargo and we get to the other side in the ship, we may be in trouble. If that entire package needs to have all of the cargo containers and one of them was wrong, now we've got to wait 2 weeks for the ship to sail back. If we had the aircraft, that latency is much lower, and if one of them was wrong, we can make that correction in a much shorter amount of time. So latency is very important if you need quick communication between both endpoints. So which do we want? Do we want bandwidth or do we want latency? Well, in a perfect world, we want both. But in a world where we have shortage of resources and we have to prioritize, you really need to look at your application and understand, does it need to communicate back and forth between the endpoints on a regular basis? Or do we really need to push a very large amount of data, but we may not need to have necessarily that level of communication on a regular basis? And you may not have a choice. Your application or your university or your institution may have already dictated this for you. But it's important to understand both bandwidth and latency between the points. And the final thing we want to talk about in terms of network performance in terms is if someone talks about the route or the path length, or they might also say the number of hops. It's important to know that between yourself and a collaborator somewhere else in the country or somewhere else in the world, that data transit, that path may not be the same every time. Fortunately for us, networks in the world are reasonably robust. So if switchgear goes down in one center, it may reroute your packages a different way. That, on the other hand, may not always give you the same performance. And it's important to understand that if the route changes or the path length changes, then your expectation in what your available bandwidth or what that latency is going to be may also change. So be aware if in one particular day suddenly you're moving at half the speed you were before, you might be told to check your path or the route to see if it's going through a different direction.